Okay, I think we're actually sending the bits back to all the places now. Welcome back to the stream, folks. Still trying to stream every day, although the timing has been a bit chaotic. I'm wondering if maybe I should try to embrace the chaos and just alternate between the really early and the really late streams here. So some days I'm just like continuing with a project through the late night and then into some other stream in the morning. And other days I got a bit more of a break to do unrelated things. Anyway, today's stream comes a little later than I would have liked, but mostly because my head is full of trash right now. I've already consulted with the doctor about my head being full of trash, and we're working on it. In the meantime, though, cats. Took was yelling at me for something just a minute ago, but now he's being pretty chill. So on the last stream, this machine, which is sort of an old 486-based voting machine that we're trying to run Linux on, I was mostly getting network access on it through a PC card slot. It's in need of some IRQ debugging for that to actually be working properly. And I think the next step in that IRQ debugging is to go back into the kernel debugger and take a closer look at the actual IRQ scanning and allocation procedure that's used for both the kind of card notification interrupt and the interrupt that the, in this case, network adapter is actually trying to use to communicate signals back to the main processor. So that's kind of the most pressing kind of debugging challenge right now, is to get a reliable network connection. I need a working interrupt channel on the PC card slot, and that doesn't seem to be working right now. It would also be nice to have some more local storage though, and I happened to get just one of those passive PC card to compact flash adapters in the mail today, which is a very simple thing, but was a thing that I didn't actually have handy. And so we can actually try sticking some more compact flash cards in this machine. My understanding is that the BIOS doesn't know anything about the actual PC card controller here, so the BIOS doesn't have any way to, say, boot off of one of these card slots, but the BIOS does know how to treat the compact flash card slot as a hard drive, which is how it normally boots. And so that could contain a small bootloader image, while perhaps the PC card slot could contain a larger file system that only Linux knows how to access. And the bootloader and BIOS don't have to care about in that case. So we've got that theory to check out. So I've got this passive CF to PC card adapter that came in. I've got a couple of actual CF cards that were too big for the BIOS to recognize normally. So the 128 meg card, and I also have this CF to SD card adapter, were both causing the machine to not actually even boot when they were in the regular CF card slot. So we can see if this is maybe a workaround for that, so we can get a little bit more storage locally. Sorry if I am making weird noises sometimes. My head is literally full of trash right now, and it feels terrible, and this might not be a super long stream. Alright. Tuco. Maybe we'll just share the camera with Tuco. Yeah. People probably remember these, right? Pretty inexpensive. I picked up a cheap one on the eBays. These are literally just wires It's just a compact flash card slot on one side and a pcmcia shaped thing on the other side. But they don't have to have any electrical adapter in there. It's entirely passive. And then got this thing here, which is a little bit sketchy. It is inexpensive. Like, I forget how much these were. They were pretty cheap on like eBay and AliExpress and whatever. It's a compact flash card shaped thing, which also has an SD card slot on it. And from what I've read, this is using some kind of pretty common IDE to SD bridge chipset. So the same chipset appears in some adapters that you can buy for like retro computing purposes, and it's in these cards, which are mostly sold for use in cameras. So it doesn't seem to be like a general purpose microcontroller contraption so much as it's like a parallel ATA specific bridge chip. But it, of course does actually have firmware and does actually have a microcontroller in there. So it might be an interesting thing to actually dig into at some point. The slot is very stiff, but you can theoretically, put whatever in there. I have a couple of these SD extension ribbon cables. So if I can actually get this to work as a usable storage medium, one thing that would be super convenient is if I could extend the SD card slot outside the case of this machine using one of those ribbon cables. So even if this is secondary storage, as long as I have something I can boot off of on my main card, and I can access this and copy stuff onto and off of it, then I can have a reasonably reliable self-contained system without having to worry so much about losing the ability to boot. Oh yeah, and I don't actually know if this works. I was trying to actually test it out using a, what is it? I've been using this kind of ridiculous contraption actually to write the cards for this machine. This is cat-proofed, of course, for Tuco, but it is a USB. Yeah, this one's actually USB 3, although I'm only actually using it at USB 2 on the Raspberry Pi. It's a USB 2/3 serial/parallel ATA adapter. So it's got a 3.5-inch flavor, like 0.1-inch header over here. And then I've got the 2.5-inch drive flavor 2mm pitch header connected to another adapter that goes to the CF card slot. So I was trying to use this with the, oh gosh, it's a little bit stiff on the insertion too. I was trying to use this configuration, and it's very unreliable. It seems to mostly detect the size of the card correctly. Reading the card seems fine, although I didn't test it exhaustively. Writing the card was super unreliable. It seemed like it would often just lock up the entire controller so that I would have to unplug the device when I would try to write to the card at all. So I don't know how much of that is like an incompatibility between the two adapters and how much of it is just this card being super flaky and how much of it is just this thing being flaky. So there's a bit of a hazard there. Yeah, the long SD card cables can be kind of hit or miss because, of course, they're wildly violating the actual electrical specifications of SD cards. But a lot of devices run the SD cards way lower than their maximum transfer rates anyway, so like you usually get lucky with them. And it's super convenient when they work. So, gosh, I think I'm just gonna boot this machine up and put the card in. I could fuss around with like rebuilding a fresh image for it or whatever, but I suspect past me left something reasonable on that CF card. We'll see if that's a good assumption. Can I make this bigger? This clearly needs more cameras. Let's just make this bigger. One of these days I'm going to debug why my OBS setup is so sluggish right now. Can't occlude the cat. 0 cat occlusion. Okay, I'm gonna turn off like half these lights. That's fine. Oh gosh. Oh yeah, do the, oh, that is still so bright. Beep beep beep. Do the beep beep beep. Is that mostly the ring light? That lighting setup is clearly not optimized for this. Welcome back to the stream, folks. Okay, so this is running that slightly overcomplicated init script that I wrote last time. Instead of dropping into a regular Alpine OpenRC user space at the moment, it's running a single shell script which tries to pivot to a network block device-based root file system. And if any of that fails, it just drops to this rescue shell. So it's failed for a pretty mundane reason, which is that I didn't bother running the network block device server. So I guess I could have started that. I don't know how much I care. Since we're already at a point where we have a kernel and some drivers, including a PC card driver and the PC card user space, and our patches to actually fix the memory allocation on this board for PC cards. So we're still dropping interrupts. As far as I can tell, those interrupts are just going nowhere. Like, I haven't actually had time to research this between streams, but I think there might just be some kind of interrupt gating at the chipset level that we're missing, because the interrupts just seem to be dropped if we look at proc interrupts. So we have a bunch of the normal stuff, timers, parallel ATA. I think that PC card interrupt right now is just being used for insert remove. So I'm guessing there's maybe some chipset level gating that needs to be enabled for that to actually catch interrupts from the rest of the system. But it looked like when we did like poke into the initialization code in the kernel debugger just briefly on the last stream, it seemed like the IRQ probing was just entirely failing. So there might be something that's even preventing the card insertion interrupts from working properly, because it seems like the driver is falling back to a polling mode, and it's just not even using interrupts for card insertion, but just checking every second to see whether the card states have changed, which is also not great. So I'm going to try putting the card in. Just to maybe keep things simple, maybe let's not try the weird, untrustworthy adapter, and I'll try just like a regular 128 meg card, which is, it's like a standard card. It's a SanDisk card, 128 megabytes. I think it came with a camera that I used to use a long time ago. But nevertheless, it did not work with the BIOS in the Super I/O based compact flash card slot. So I'm going to try to hot plug this. Oh, you got a new device. Wow, we have an identification. So 3COM3C589B is the network card, and then SanDisk SDP, I guess, whatever, is the network, or is the disk that I just put in. I thought I compiled in a driver for PC card memory. Oh yeah, parallel ATA pcmcia, I think that might be it. Oh man, we have dev SDB. Brilliant. Do I even have fdisk on here? Oh yeah, this is a disk. That's great. That was painless. Can we write to the disk? Let's try partitioning it. Cool. I guess I only have makefs vfat here. I mean, I could actually install other tools, right? I have a network connection. What is that package even called? Oh, my head is full of trash. Oh, that's an interesting tip from chat, is that sometimes adding some copper tape to those extensions, those SD card extensions, presumably as like a shielding, helps the reliability. I'd buy that. I assume you have to ground it. Oh, my brain is just leaking out. It's turning into jello. How do you make FS Alpine? E2 Fest Progs. We can do that. Yes, I know everything's terrible. Stop it. No typos. Everything is made of terminal overlap and typos. Right. Chico probably appreciates the lower light anyway. Am I just missing root certificates or something here? Anyway, I could try to fuss with root certificates. It seems like APK intended to have its own fairly self-contained SSL setup, though. Oh, is this a time thing? Probably. Hello, 2099. Does that help the SSL go? I should probably just stick that in my init scripts. I didn't unhook the CMOS battery intentionally, so I think there was an event at some point where the BIOS wiped the CMOS memory, so I'm sure if that happened, it took out the clock. And I think the BIOS is resetting the clock to 1999, and then Linux is interpreting that as 2099 because it's just like way past caring about the 20th century. Yeah, that was definitely the problem. It seems like it's actually doing something now instead of just immediately failing. It'd be cool if we had an activity light. I don't think we have one. Wow. Right. I don't know what the upper limit of card size is going to be if this one even works at all. 4 gigs is probably plenty for this system. I don't know. So the story right now with the network adapter is that it's probably performing much slower than it even normally will. It's not going to be a speed demon under any circumstance because this is a 66 megahertz 486 and the network adapter is 10 base T. But we are also completely dropping all the interrupts, so it seems like there's just some fallback of polling that's keeping it going at all, and that's what we're relying on. So the network is high latency. I've been mostly seeing pings of like 20 or 30 milliseconds. Oh man, we can do makefsext4 on dev SDB1. That's great. Just trying to copy some files to the card to test out write performance, maybe. Even though I'm not actually measuring this, I just want to see if it works, basically. Seems usable. I don't know if the parallel ATA driver would be even using interrupts. It's quite possible this is entirely polling. Okay, I'm going to try a bigger card. Can I not control to see this one yet? Oh, man. Be cool if I could cancel this. It's of course tempting to power cycle, but I don't know if that would actually be faster. I love a responsive computer system. We'll just copy everything before checking whether there's any input. Oh my gosh, okay. Cool, so I can eject just the card I'm actually trying to eject. I should have unmounted the file system first, but whatever. I'm actually trying to keep that file system. Okay. Card. Okay, this is going to be an a CF card adapter that has basically an SD card to micro SD card, and well, I was going to say it was stuck in there, but I guess I just pulled it out. The secret is to use more fingernail. And then inside that we have an actual 4 gigabyte micro SD. Let's see if this is actually successfully a storage device. Did we just crash somehow? Oh, maybe there's a hot plug problem. I guess I'm rebooting. I think I checked, and getting that flexible SD card slot or cable thing out of there is still going to require me cutting away the PC card slot casing just a little bit, but I don't know, if the rest of this works, that's totally worth it to me. It means being able to actually swap storage devices without completely disassembling this thing once it's actually together. A Key Technology Corp FC1307. That is the bridge chip in that controller, in that SD to CF card controller. Because remember, the CF to PC card adapter is passive, so it doesn't have any chips in it, it's just wires. But the IDE interface itself is provided by the thing that's pretending to be an IDE hard disk, which in this case is the PC card, or the CF card to SD card adapter. SDB. Right. Another driver that maybe I should not have modularized. Okay, now I have SDB. Huh. Is that right? Is that actually 4 gigs? Huh. Gosh, I could like partition this GPT if I wanted to. Should I just do that? Oh, can I not partition GPT from here? I don't know why this one can't do GPT. Whatever. I thought it'd be funny to use the GPT partition table in a 486. Oh, right. Is my clock broke again? Without a knit script, am I missing like a hardware clock update thing? I should really just put NTP in my hardware clock and knit scripts. Especially because I've got my own local NTP server here. It's not like I'm even bothering anyone else's by pinging it a bunch. Okay, so making some changes for next image. Have some automatic MTP set up. Hey! 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 Excuse me. Oh, did I not even tell this kernel about GPT partitions? It's maybe moot if I didn't even tell the kernel about those. Like, whatever, I'm just trying to do something silly at this point. Yes. It's actually reasonable sound insulation except that dripping gutter. Oh, that's a cool idea. To edit the BIOS disk geometry configuration by changing the CMOS memory directly. Yeah, I'm curious if that would work. The way that the BIOS seems to store this is by having a disk mode number, and then that mode number looks up a CHS geometry in the table. A lot of BIOSes that do that have like one of the mode numbers reserved for custom, but I didn't see that here. But, you know, I assume that this BIOS is built on the same code base as a lot of BIOSes that do have a setting like that, so it's probably not too big a stretch to hack it in there. Oh, are we out of space here? I mean, it says partition or permission denied. We do have space. I wonder if this is just failing because of dropped interrupts and stuff timing out at weird points in the protocol. Alright, this is like kind of where we were getting last time. It's like we sort of have networking, but it seems really unreliable, which is about what you'd expect if all the interrupts were getting dropped. Like when all the interrupts are getting dropped, you basically only notice that new packets are available by accident. It's like if you happen to be sending something to the card and you notice, oh, you've got some data for me too, I'll take that while I'm here. But that's just the only way you ever get data. Yeah, so that's kind of flaky. And I'm just going to use regular fdisk anyway because kernel partitioning. Cancel harder. Hey, Tuco. What are you doing down there? Do you want to check out the rain, Tuco? Tuco, you want to check out the rain? Yeah, that's what he wanted. Yeah, there's a comment that this sounds like a bad way to use a network card. Yes, yes, I agree. And it probably works less badly for some protocols than others. Oh, Tuco, you're up here now? Oh, careful, don't do that. No, don't. Fuzzo. Tuco, you're making me nervous, honey. Oh. Don't you dare chew that LVDS cable. Oh, gosh, Tuco. Hey, sweet boy. Oh, this boy is made of softness and love and screams. One other thing about the BIOS, though, is I don't actually know where the BIOS even enforces its limits. I mean, we've already established it's, like, not most places. So far I've been having trouble getting it to boot without getting at least the number of heads and sectors per track to match, but I didn't really work too super hard on that. It might be something to revisit. Tuco, we have several of you on the screen. That monitor is apparently brighter than real life. Oh, Tuco, I gotta get all this stuff out of your face, those little crusty bits. Tuco. You're right there again. Oh no, did I just rearrange my screens? Okay. Such partition. Right? That's great. That seems to be full size and seems like we wrote the disk successfully. Well, yeah, compared to networking, storage has been pretty uneventful. I bet this would have actually worked without even fixing the memory mapping bug because, oh well, no, because these, yeah, I guess that's true. Even if you're using this in ATA mode, which I think is what this driver is doing, you'd still need to map a little bit of its memory for the card information structure. So I was thinking you could use a card like this without even having a working memory mapping, and you could, but I don't think Linux would, because I think Linux would still try to memory map the CIS. Oh my gosh, okay. Oh man, can has mount. Oh. I actually kind of wanted a dash V on there. It's also possible the disk driver wants interrupts too, it's just not complaining when they're missing, like the network driver is all the time. Oh man. I also kind of wanted this thing to run an SSH server, but I was keeping that on the larger disk image. Sure does take a while to control C stuff that's doing storage. Tuco, you coming back over here? Anyway, this should just be a nice little extra chunk of storage I can use, although, you know, in between times in which the entire system is frozen for one reason or another. Oh gosh. Huh. Well, this is working way better than it was in the adapter. I mean, the SD interface is working better than it was in the USB adapter. I would try to do some transfer rate tests or something. I don't know how much I care though. Like, these cards are so slow at the best of times. 2 goes back on the warm spot. Can we look at that probing, like IRQ probing code while this is doing its thing, maybe? Head is full of trash. Oh, why is it copying proc? I thought -X was there to keep that from happening, but maybe copy doesn't know about that. Sigh. Yeah, I don't think I'm actually going to prepare the disk image like this. I think I probably actually just need rsync. And or to unpack a fresh image onto this card from a different machine now that I know it seems to basically be functional. Rain noises are kind of nice. So this is the one physical IRQ we have. It seems like that part worked fine. Right, this is where we're ending up. We have this pole interval set to 1 second by default. Oh, don't copy /proc, please. Oh my gosh. So set bridge state, CSC in 0. Yeah. Right, this is the sketchiest thing. Testing ISA RQ. Make sure that it isn't hit during these 10 milliseconds. Then generate one interrupt and make sure that we had exactly one hit. I mean, sure. It's just, ah, man. Things sure did improve with PCI. So, is there anything weird about how these are implemented on the particular chip we've got? Oh, I can't cancel the copy. Just copying proc. It's copying proc K-core. Well, we're giving the card a workout. Oh, there's a registers amendment. Does this have anything important? You always have to read the errata, because there's always mistakes in the documentation for these big chips. It's still trying to copy K-core. Oh, programmable interrupt timer count. PS2 mouse buffer. NMI gate. Software DMA request. This is mostly stuff I don't expect her using much. DMA. Parallel port 2, we're not using any of the on-chip parallel ports. The one actual parallel port we have is on the Super I/O chip. COM2. Divisor must be non-zero. I was curious about that. Theoretically, I think a divisor of 0 would let you... So, like, it isn't actually divide by 0, it's like the register value plus 1. So normally it's dividing by 2, and that's the minimum divisor you can get. I think some UARTs let you go to higher speeds, but here they wanted to clarify that that's not supported. 115/200 is it? Let's see. Anyway, so far nothing interesting. Parallel ports. Non-deterministic bits in the parallel port registers. I think that's just the power on state though, so that's fine, like whatever. DRAM pre-charge delay off by 1. Visa local bus reset. Linear ROM CS0 shadow. Now we're getting closer to stuff we care about, but still not quite. No support for 0 wait states in fast ROM mode. More ROM chips like stuff. We are only using that for BIOS. Oh, power management. Which we're only... I don't know if Linux actually supports any of the power management features on this chip. This chip has some support for automatic timers to switch between modes, and it has several different lower clock speed modes besides the maximum 66 megahertz mode. Which of course it gives a name like hyperspeed or something. Oh. Apparently there is a way to tell it to overclock. Somebody asked about this earlier. Somebody was asking if there was actually a way to overclock the chip. And I was saying that it was unlikely that you could just supply a higher input frequency because there was such a extensive set of PLLs on the chip. Like, it probably wouldn't lock if you changed the input frequency too much. But it looks like you can switch it from clock doubling to clock tripling. Yeah. Apparently it significantly increases the heat production. But maybe if you cool this thing specially, you could actually go from 66 to 99 megahertz. Oh. Oh, wait, the errata here was that they documented a 99 megahertz mode that should have been 100 megahertz. How does that happen? That's so weird. What are the AMD approved operating conditions for clock tripled mode, I wonder? Are we still trying to copy K-Core? I should just reboot and redo the formatting on this disk. Yeah. A lot of these are just like fairly mundane documentation errors, as you'd expect. Okay, PC card controller. Oh. I think they mentioned that they supported a non-standard IRQ6 here. That's funny, they added a clarification here that just explains that IRQ6 was added to support some particular floppy device. Yeah, okay. Oh my gosh. I wonder if we have any DD options that'll give us progress. It should at least give us overall speed, though, if we try to DD, for example, the network block device to the card we just added. Like, basically just a copy between the two PC card slots. Right. Let's try maybe not mounting it. Yeah, I don't think I quite have the clarity of mind or cranium right now to do much serious debugging, but we can try a little bit of like copying this and see how well that works, and then I might have to wrap this up. Hopefully come back tomorrow with a head that's not full of garbage. Can we do better with a higher block size? Thanks for stopping by and chat, and thanks for the kind words, folks. I'm complaining about this, but we've almost copied an entire 10 megabytes. I still can't cancel it though. But yeah, so we're still having that interrupt problem, of course, because I haven't actually done anything to fix it. But both card slots work, and that's convenient. I wonder if there's a practical limit to how large a card we could put in here. Gosh, why is this so unresponsive? PC card IRQ routing. Mostly standard. How does that probing work? Yeah, it's trying to issue a software IRQ. I wonder if that functionality is implemented. Huh. card detect and general control. Really? Okay, yeah, so this should match up with the socket A indexes or indices up here. I have to verify this, but the lead that I'm following right now is that the IRQ probing is not potentially working because maybe the function that they're using to send a software IRQ to probe the IRQ might not actually be implemented. There's a question about whether I'm taking a significant performance hit as a result of the interrupt issue. I mean, I haven't systematically measured it, but it certainly seems so. Just doing pings on machines in my local network here, I'm seeing latencies of 20 or 30 milliseconds, which even for a machine this slow seems excessive. And I've been getting just timeouts where I wouldn't expect them, doing things like APK update. So yeah, I haven't done any micro benchmarks on it, but it's acting extremely flaky. Okay, so far those match. IO window control. Start addresses. Right? I'm looking for register 16 hex, and this document just skips right over that. The heck? So we had all these mapping addresses before that, and then it skips right to 18, which is more addresses. Is the other one they're missing too? These two are missing, 16 and 1E. Can we avoid those? What are these even? Am I gonna have to look up the spec for the original i82 365? This gets set to 0 a couple times. That's uninteresting. GBL control, engine control. Yeah, really? Do we have anything? Oops. Yeah, maybe that's just for some like testing features or something that this chipset didn't implement and Linux doesn't use. Cool. Oh, and this one's only used for the software error queue. Yeah, interesting. So yeah, I could probably just read the i82-365 docs on this. I'm guessing it's some kind of like test register that this chip didn't bother with. And now Atom is refusing to render a bunch of the text on my screen. That's great. Why have a text editor even? Okay, generate one interrupt. So how do I just disable this entire probing operation? I don't know how we do better than this fallback we've already got. Like, all this can fail, which presumably it is, and then we just fall back from scanned to the fallback path, where we definitely are, because that's where pole interval is also getting set. And so here we're doing some kind of weaker IRQ check, it looks like. Yeah, I don't see how this could fail unless there's just Linux drivers using everything. Okay, so what about CSRQ? This thing is still copying at 150 kilobytes a second. I would expect even if, yeah, I would expect the write speed on this card is probably not quite as high as 10 base T, but this is still much slower than expected. Oh gosh. I should really take, I should really take a closer look at the D message output and see exactly how it meshes up with what we're seeing here. And get a clear idea of exactly what's working and what isn't. I think I'm gonna need to just wrap this stream up though. My head is still feeling just distractingly bad, and I think I just need to regroup and come back to you literally a little more clear-headed tomorrow. But at least we kept up the streaming every day. Pretty uneventful PC card situation though, right? I don't think it's a flu. I'm not here to talk details about what's going on with my head. It's just in a bad state right now. It might just be like a cold or something. It might be something more like an inner ear infection. But it's also none of your business.